you are.
All right, so I'll kick things off. My name is Mark Boisvert. I am a product manager at Continental Resources, and I manage our Palo Alto Networks product line. I'm joined by your presenter today, Chris Motley, who is a systems engineer for Palo Alto Networks. And I want to thank everybody for joining this morning for the anatomy of the hack. Should be an interesting session. So if we can, what we're going to do is just give a little overview for those who do not know who ConRes is. We're going to give a couple quick slides. I think some of our customers are on this, but founded in 1962. So we're over 50 years old. We're a privately held company, woman-owned. So if anybody has a requirement for doing business with a woman-owned business, we can definitely help with that. We have offices across the United States and have the ability to ship globally. We currently ship to APAC, Europe, and Canada with ease. Our focus practice areas where our company has the most resources and where the company is investing is obviously networking and security. Cloud is a big one. Collaboration, which is voice and video conferencing, and obviously the data center isn't going anywhere. From the value-added services standpoint, we have a professional services team that is nationwide, 75 plus people that fit into those different practice areas, as well as a managed services group, or NOC, that's 7 by 24, 365 days a year, that can help with a long list of deliverables. We offer our own internal leasing, and we have large rollouts, which a lot of our customers do. We have a 50,000 square foot integration and logistics facility in Nashua, New Hampshire. So not only can we warehouse, we can ship globally, but we can do full rollouts for products. And we are Palo Alto Networks Platinum Partner, highest level. And on the next slide, we're just getting a little bit into what the services that we can provide you. Obviously, we can do professional services. We can do the install and configuration. But we do have our hands-on evaluation equipment. So we can get you no-cost loaner equipment, either a license or a physical box, as well as we have our own Palo Alto Networks internal labs. If you want to test drive the product, kind of like today, you're going to see anatomy of the hack, we can set that up for you on any of the platforms. We can provide health checks with reports of your current environment and where you might be having some issues, and again, the professional services piece. So I'll turn it over to Chris, who is going to give the presentation, and sit back and relax.
All right, thank you, sir. Hey, everybody, Chris Motley again. I'm a systems engineer in the New York metro area with Palo Alto Networks. I've been here about 3.5 years, working with the product for about 10 or so now, so basically since the beginning. What I'm going to go through today is something that's going to illustrate a lot of the different pieces of our next-gen security platform. From the next generation firewall, which most people know us by, to our endpoint protection called Traps. We're going to show you some of the integrations between the products and our threat intelligence cloud, using a product called Wildfire, as well as a product called Autofocus. But just so you know, this is not the extent of the services we offer. We have deep integrations with a lot of our partner products. If you look on the left-hand side here, you know, VMware, AWS, Azure, Splunk, Tanium, Aruba, Proofpoint. I can go on and on and on. But we are really big on ecosystem partners and people that sort of work at the best, at the top of their space. We like to work with best-of-breed technologies, and we like to share information with them. So what you'll notice is the threat intelligence service that we have, called Wildfire, integrates with a lot of these other products. Even some of our competitors, like Carbon Black, you'll see an integration whereby they can submit data to our threat intelligence cloud for verdicts. We also have a founding membership in the Cyber Threat Alliance. This is an information sharing consortium between actually a lot of competitors. So companies like Cisco and Fortinet and Checkpoint are members of this alliance. And we're actually sharing, we have a minimum amount of samples that we actually have to share with each other every day, and they have to be unique samples. And then at the top, you can see Unit 42, which is our threat intelligence team. These are the guys that are doing the research and finding the campaigns, finding the bad actors out there, and then providing color and also descriptions into our tools to better illustrate or better protect against some of those larger campaigns. So one of the things that you'll see is a lot of people are familiar, again, with that next generation firewall and the advanced endpoint protection. But what we have is a framework that we're starting to build, and this is sort of the next generation evolves to, the third evolution of that. And what we've built is this application framework whereby not only our own application developers, but also third-party and customer applications are going to be able to leverage the same rich set of data that Palo Alto Networks provides and be able to get their own view into that data. So we are building a logging service, which is actually cloud-based, and you're going to be able to store terabytes and terabytes of data up there in a highly redundant fashion, enabling you to then search and correlate that data amongst many tools, not only the firewall or the advanced endpoint, but the cloud, so things like your SaaS applications or your public cloud or your IaaS or PaaS like Azure and AWS or Google Cloud. So we're going to enable a very robust framework that's going to allow all of the data that you guys are collecting through these sensors, these endpoints, as well as through other third-party tools. And this logging data is going to be there and available for anybody so that it's much, much easier to consume without actually having to put another device in line or another sensor in the network. So I just want you to see where our platform is really going and where it's headed. And I think the industry in general is actually doing this quite a bit. So moving on to what we're going to see today, we're actually going to be looking at the anatomy of how a piece of ransomware actually gets into our network. And so just a really quick overview, this is what my network looks like. So I have a victim machine here that's running Windows 7. It's an unpatched version or a lesser patched version, but he's running traps. In the initial steps, I'm going to have that protection turned off. He's going to be receiving a Spearfish email from an attacker PC. That attacker is then going to use that Spearfish email to compromise the victim's endpoint. He's going to then deliver a piece of ransomware, and you're going to see what it looks like from the back end as well. I'm going to show you from the attacker's perspective what it looks like and what all I can do once I've gotten control of that machine. Once that's done, I'm actually going to enable protections on the firewall and then subsequently on the endpoint side to show how Palo Alto Networks actually prevents against these attacks, and not just one protection or two protections, but up to 13 or 14 protections that we can set up in order to prevent these attacks from happening. So the workflow of this attack is as follows. The attacker sets up a web server, a malicious website, to be able to deliver a flash exploit. He then crafts an email to the victim trying to get them to go to that website. The victim clicks, launches, and pulls down a browser exploit, essentially. That exploit compromises the machine and calls home to the attacker. The attacker then has a full channel to basically go through and attack and actually take control of the endpoint. So without too much more, I have one more slide that I'll show you guys towards the end, which basically comprises all of the protections that we've gone through. So let me jump into it. I don't like to do too many slides, so let's just jump right into the demo. Can everybody see my screen? Everybody see the email with the cat on it?
See the kitty cat, yes.
Yes, sir. Okay. So what you're seeing here is the Spearfish email. People see funny emails all the time, and they click on them. I'm just going to pretend that I'm I'm the dumb end user here, and I'm gonna do my best to, go along with this attack. So what you'll see on the right-hand side, this is my Linux server, and it's running Metasploit, which is an attack framework. This is used to exploit and to take control of endpoints that have essentially gone into the malicious website that I'm running. So if you'll see here on the link, it's going to mycats.catserver.com here, and it's going on port 8080. So what I'm going to do is I'll just click on it, and I'll show you what happens. If you notice, when IE opens up, you'll see on the right-hand side here, I'm actually sending the malicious flash file right here. And without any real interaction, the user just seeing a web page that doesn't look like it's loading, I've actually got a back-end command and control session already to the end user. So I can interact with that. And I'll show you, just to prove that I have control, I'll open up a good old calculator window. And so you can see on the Windows machine here, I've opened up the calculator. That end user didn't do anything, right? So that means I have full control here. I can do things like take a picture from his webcam, and you guys will be able to see what it looks like in my home office. There you go. So I've actually been able to take control of not only the webcam, I can also go through and pull up a keylogger, so that when this user, if they are doing something else and they go to something like Bank of America, and whether or not that website loads, you'll be able to see that I've already gathered the keystrokes from this user. And you can see that very quickly. You can already see what I typed into the keyboard, bankofamerica.com. If I were to type something like username and password, you'll also see that shows up here. So again, I'm pulling all the keystrokes right from this endpoint over to my machine. Now, I can sit here and just do that all day, every day, and maybe get some credentials, get some information. But if I'm really doing this at a fast clip, what I'm likely going to have done is automated the uploading of a piece of ransomware or something like that, so that I can just move on with my life. I don't want to spend, maybe 10 hours doing this, trying to compromise some credentials. Maybe I'm just looking to make a quick hit and get a couple of dollars out of it. So I'm going to upload a piece of ransomware. And that's already uploaded to the machine. And I'm going to execute it. Oh, actually, let me do one more command before I do this. Let me just prove that I can get all of the usernames and passwords. So I basically have pulled the username and password for the administrator account, which basically gets me credentials I can now compromise and crack. Once I've got those credentials, I can now move into the rest of your domain and essentially pull, from other machines as well. So I can find other machines in the network. I can then start cracking those passwords, or using this password if it's across multiple machines, and essentially I gain control of your network piece by piece. So what I'm going to do now, again, is go the easy way and execute my malware. So what you'll see is I've spawned a process here. This guy is going to go into a boot cycle. What you're going to see is a screen that looks like it's actually running check disk. So most people won't interrupt check disk when it's running. But what it's actually doing is encrypting the master boot record on the machine. And so you see that the flashing skull of death comes up. No good. Everybody starts to panic at this point. Now we have instructions on how to download a Tor browser and get set up with Bitcoin and go and pay the ransom essentially to unlock this machine, which who knows if it's actually going to give you your computer back. Sometimes they do, sometimes they don't. The point of the matter is my machine is compromised, and so I am now SOL, and I need to basically either reboot from snapshot or rebuild my whole machine. So what I'm going to do is I'm going to restart the whole exercise now and show you essentially what Palo Alto Networks has already seen, because essentially I had a firewall in place already that was in there and not in protect mode, but was in alert mode to show me all of the different settings and different viruses, spyware, all the hits that I would have seen in my security policies. So what I can do is I can take a look. That's my IP address right there. And you can see under the threat logs all of the things that were happening. So if you look at today's date, right, 404, you've got suspicious TLS evasions, client and endpoint exploit detection, so looking and fingerprinting the endpoint that I'm running to see what it might be vulnerable to. Then you can see the Adobe Flash Player Flash file that I was using based on the application Flash. You can see the reverse shell that was sent back to the attacker's machine in order to establish that command and control channel. And then you can see the virus, the actual exploit, ransomware that encrypted the master boot record. So you can see all of these protections in an alert mode, which basically just means show me what's happening, but don't do anything. Well, now I'm going to turn off that alert all policy, and I'm going to turn on some policies that will do some blocking. And what you'll see is that as I do these, any one of these protections will stop the attack in its entirety. So I'm going to enable that policy, and I'm going to commit this to running. Once this goes live, what I'm going to do is I'm going to restart the attack and show you guys what actually happens. So this guy is ready to go. And once I open this up, you're going to see that I've got my whole setup again. It's almost done. Okay. So back to my cat. Click on the cat picture. All right. Immediate block. So when I went through this time, I actually went and stopped it by the URL. Because it was a URL that I didn't know or I didn't trust, this guy got immediately blocked. The attack doesn't happen if that's going on. And so I'm able to thwart an attacker just by the URL category he's going to. The next one I'm going to do, and I'm setting this up while I'm talking, is blocking the actual vulnerabilities that came across. So once this goes, let me just wait 2 seconds here. You're going to see that if I can't get my vulnerability, the thing that's going to do the exploiting of the system, if I can't get that delivered successfully, I also can't do the block, or I can't do the full attack. So when I click through, you're going to see now it just failed. And what actually is happening on the firewall side, and actually let me preload one more thing just to get it ahead of schedule here. If I go into the monitor tab, you're going to see that now that the vulnerability that I had, that initial one, that Metasploit client environment exploitability detection, this guy's actually getting a TCP reset. So I've killed the attack by sending a TCP reset and shutting down the connection. So if you look at this guy, that's why this shows the navigation was canceled. Attack's done. Nothing ever happened. On this side, he actually tried to send a redirect, and it didn't work because initially when I was gathering this target information, you see here, this is that fingerprinting step that I was doing. And when I'm fingerprinting, I use that to figure out what version of Flash or what version of OS he's running, and then I send the appropriate payload. If I can't do that, then I don't know what to send, and the attack essentially fails. So moving to the next step, again, I'm going to block the virus piece of this. So go through and try and reload this again. And what you'll see is as this attack proceeds, you're going to see that more and more steps of it happen. So you might see again, a redirect here. So I've added this a little addition here. But what's happening, again, you're going to see that when I send the flash file, the weaponized flash file here, it's not going to work because, again, I've caught the virus. So let me just keep moving on here. And then I'll explain what just happened. So now you can see in the threat side, I had a virus now coming across and getting reset. I didn't log all of the other vulnerabilities just because I didn't want to make it cluttered, but this would also have seen the vulnerabilities that I saw before. But in this case, I just want to show that the virus piece of it, which is that weaponized flash file, got reset, thus stopping the attack again. So let me just make sure I'm good to go. I am. Going back into my attack one more time, you're going to see that when I make the connection now, it's just not going to, it's going to hang. And the reason for that is not because of a virus or a spyware detection. It's a really simple one. It's actually based on the ports that it's using. So I don't really want to allow my users to browse on port 8080. And so I've created a policy here that says only allow the default ports. And this is not even tied to an application right now. This is purely tied to allowing port 80 and blocking others. Right. Say that again? Sorry, I heard a question. Okay, if you have that question, feel free to interrupt again, no problem. But right now what I'm saying is in this configuration, I'm just showing that the attack uses a non-standard port, and so I'm able to block based on that port being non-standard. And so what you'll see in the logs, in the traffic log here, you'll see that I'm denying the 8080 traffic, whereas before it was being allowed just because of the nature of my policies. So I've been able to block this. You get a policy deny action there. So next step, okay, so let's let that go. Let's let the let's let the non-standard port go. What I'm going to do now is I'm going to block it based on the fact that it's not using a known application signature for the callback. So once I actually deliver that flash file and it compromises and tries to phone back home, it uses a reverse shell, and that reverse shell is not a known application. And so I get to block it based on the fact that it's an unknown app. So let me just verify I'm good, and I am. Clicking on this again. So you'll notice it goes through the progression this time, and you see it sends the flash file here, and it sends the stage down to the compromised endpoint because now the exploit has actually taken place, and I've sent the weaponized payload down that I want to establish the command and control traffic back to me. But because it's using non-standard TCP traffic, and again, let me just move on to the next one here and commit. Because I was using non-standard TCP traffic, you're going to notice this unknown TCP on port 4444 getting denied now. And the reason for this is that my firewall didn't have an application signature for this traffic, and it blocked it. It also could have blocked it based on 4444, but it's one of those things that you're going to see in the network periodically. So I can go through. I've got one more that I really want to run right now. And I can go through and I can actually just block this based on the region it's going to. And so what I've done in here is I've actually set up a policy that says block geographic IPs based on this malicious region. And that region just happens to contain the one IP address right now. But I can use this to block country codes. I can use this to block things from places I don't do business. So if I don't do any business with China or Russia, I can block those country codes. If I don't do anything with the Baltic states where there's a lot of malware coming out of these days, I can block those regions based on their ARIN or APNIC or AFRINIC, whatever registry they're using, based on those source IP ranges. So those are the protections on the firewall side. And that's not all of them. That's just a good representative sampling of them. So what I'm going to do now is I'm going to turn off all of the firewall protections and go back to my alert all policy. And what I'm going to do is I'm going to show you on the endpoint, and this is just going to log me out. So I'll just log back in here. And what I'm going to do is I'm going to show you now how the endpoint works and how the endpoint can stop these things as well. So this is our Traps ESM, or our Endpoint Security Manager. And what I'm going to do is I'm going to verify. Can somebody go on mute? Luke, I think. Getting a little background noise. Okay. So I'm going to check in. You're going to see that all my protections go red because I've disabled the protections initially. I'm going to go into my policies on my ESM here, and you'll see that Traps protection disabled. I'm going to re-enable that protection, and then I'll check in with my endpoint on here. Once I check in again, you're going to see all the protections go green. So now when I try and utilize that attack that was going on before, when I send that weaponized flash file down, you're going to see that Traps has actually blocked that because the attack was trying to access DLLs improperly. Traps is a behavior-based endpoint protection. It's not based on signatures, so it didn't have necessarily a signature for this file. Now, that's another protection I'm going to show you later on. But it initially did not have a signature for this protection. It just went based on the behavior. So because Internet Explorer was trying to do something suspicious with the DLL libraries, it's actually going to prevent this attack. One of the fun things about attacks like this is even if you kill the process, Internet Explorer is very helpful and tries to restart that same process. Apologies. It actually tries to restart the process. And what that does is just gives the attacker another attempt at compromising your machine. So what I have to do here is actually I have to go into Task Manager and kill this manually, because if I don't, what happens is it just keeps trying to relaunch. So I actually kill the program in a hard stop way. And what you'll see on the endpoint is I'll show you the security events that popped up. And you can see two of them because it reloaded itself. You'll see the DLL security module, the exploit prevention module that I stopped here. I'm going to create a rule, and I'm going to create an exception for that. And by doing that, what I'm doing on the endpoint is I'm saying, don't block against that exploit. And the reason for that is that on the endpoint, what I get is most times when there's an attack that's happening, it doesn't just hit one of these endpoint protection modules or the exploit protection modules. What's actually happening is there's 3 to 5 typically that are happening in sequence. And if I can stop one of them, I can kill the attack. But it doesn't matter which one. So even if I stop the third piece of it, which I'll show you, even if I stop the third piece of this attack, I'm actually still going to get a successful protection. So you'll notice I've added the exploitation exemption here. I'm going to run this attack again. Once again, I'm sending the weaponized flash file. Oh, and this time it's actually what they call a ROP chain, or return-oriented programming chain, detected. And so this guy is actually going to, you can see, it's protecting against that return-oriented programming, which is a malware technique that's known. Again, if I kill the process, it likes to just recover. It's very, very helpful in that respect. So I'm going to kill this and show you, again, on the exploit, it actually triggered one of our modules. So you'll see that here, the ROP mitigation piece. Again, I'm going to create an exception so that I can keep peeling the onion back here and showing you all of the protections that you get. But I'm going to go through, and once I've done that, I've created the exception. I will once again check in here. You'll get an additional exploitation exception. Launch the attack again. And once again, once that flash file comes down, oh, now I've tried to call an API from an unsafe code area, essentially trying to break out of normal operating parameters of this program. And so this is, again, the same attack, but you can see there were 3 separate modules that I triggered. Now, if I was to turn off this specific module, I'm going to have all 3 that are actually comprising this attack turned off. So I'll do that. It's dangerous. It's risky. You wouldn't normally do this in real life. But what I'm showing is how Palo Alto Networks platform gets a lot of different, to use a baseball analogy, at-bats to prevent against an attack. So again, I've turned that protection off, go to my machine, check in again, I've got my policy, and now when I launch the attack, it's going to be successful because I've turned off all those protections. So once I've done that exploit module, okay, that flash file is going to actually get through, hopefully. I may have to fire this up once or twice. One thing to note in the bad guy world, not everything goes perfectly every time. So I'm going to kill this and I'm going to start it one more time. So you see sending the flash file here. And once that is able to get to the endpoint, hopefully, there's actually an additional protection that I get when I try and deliver my last payload. And again, like in all good things, you can end up running into some endpoint things. So let me actually revert from snapshot here. This will just take a minute. I'm going to revert both of these guys to snapshot and just start it over because we know the attack worked before. I apologize for the delay here, guys. So we've got our cat server back up. I'm going to restart the Kali server as well, just to make sure everything is back and proper. So once that's good to go, we should be able to establish the connection again. I'm going to make sure Traps is checked in here. Check in now. I've got my protections. I've got all of the exploits. I've got my DNS server responding. And let's try it one last time, see if it goes. Sending the flash file here. Again, I should be able to get that stage. Perfect. Now I've got my command and control session again. And I'm back on. Again, I can make sure I'm still controlling the endpoint. Great, voila. So now what I'm going to do as the attacker, I can list all the processes, I can migrate, so I can actually, one of the things that you'll know about an attack is because this window is where the actual exploit lives, if I close my browser, and that's risky because it didn't work the last time, but I close the browser, I lose the session. What I can do as an attacker is I can actually migrate to another process. So I'll show that right now because it's really important to note that if I migrate to a process that is not, that's a system process, for example, I'm going to actually be able to persist beyond that browser going down. So if I do PS and I load the processes here, and for example, I run as something running as system, either the search indexer or taskhost.exe. There's a bunch of different things in here. Let's go to the spool serve. Actually, let's see what process number that is. 1364. So you notice I've hopped processes now. And what's happening is it essentially caused this to crash because the exploit was running. But now, when I close this browser window, you notice I'm still in here. I'm in Windows System 32. If I go to cd:// Or if I actually just go to CDC, actually, you know what? I'm not that good with navigating Windows file structures anyway. But I could actually look at the files in that directory. So I can see I'm in Windows System 32 now. I used to be in the user directory. So now that I'm in System 32, I'm actually running a system. This guy has no idea. He's closed his browser window. Nothing's happening. So that now I'm actually in control and I can still upload my file. But it doesn't really matter now because he can't kill me. He can't kill the process. I've become persistent. So I've uploaded that piece of malware again. You'll notice traps doesn't take effect right now. I've uploaded a piece of malware and it's resident on my machine. And I could even go and find that for you if you'd like. So if I can go into C:\Windows System 32. I have a file in here called Petya. And that file is actually going to be able to run this petya.exe. You notice I'm on the Windows machine. I've uploaded a file. Nothing's happened from traps because traps doesn't work until a file actually executes because that's when the malicious behavior actually happens. So once I go to execute, what you're going to see on the trap side, if I've done everything right, you're going to see an actual prevention from happening. Right, so that process started. We noticed that nothing happened on the endpoint yet. It hasn't rebooted. It hasn't done anything. Traps has just done essentially silent protection on that. Nothing was able to get through, even though I executed the file. Right, this was just a protection that was blocked, and now I've got a nice happy endpoint. So that's I wanted to go back and show you that was pretty much the extent of the protections that we're going to have. This is actually going to be caught. You're going to see that all of these exploits, again, I have 3 at-bats from the exploit side. I have the actual malware side when it tries to execute. And then I have a very large amount of protections on the firewall itself. So what you'll be able to see here is if you count up the opportunities to prevent, there's actually 20 different ways that we can stop this file from happening. So it's really important to note that, again, no demo goes smoothly when you want it to, and that's fine because that's how a real attacker is going to look. But the important part here is that I've demonstrated successfully protecting against this attack in at least 6 ways on the firewall and 3 or 4 different ways on the endpoint itself. This is how we use layered security. Again, the platform working together, talking with other components, and utilizing that sort of shared DNA of the threat intelligence cloud that we talked about before, the Wildfire Threat Intelligence Cloud, using that DNA to really prevent successful cyber attacks, which is Palo Alto Network's mission in life. At that point, this kind of ends the normal demo, but I think I might go on a little bit and show some of the other pieces of the product. So once I've seen the attack happening, one of the things that you can do is, based on the attacks that you've seen happen, right? If I go back into my threat library here and my logs and look at the attacker and say, hey, this was an IP address 192.163.217.66, I can actually use a tool called autofocus and look up the data on that. So I've actually preloaded this just for demo's sake, and I can go into autofocus, which is a threat intelligence tool. It actually is based on top of Wildfire. It enables you to search billions and billions of indicators of compromise to look and see what other things might be associated. So in here, I can actually look and see what was tagged from autofocus. This is a tagging system that can go through and show me, oh, this was used, it was a banking Trojan. This was associated with this IP address here. This was also used with another malware family called a Upatra Trojan, which is actually what delivers the dire banking Trojan. So if I go through and I look at these files, I can actually see what they were doing. So inside of this sample, again, once this loads up, I'm going to be able to see the actual breakdown of the file in my network. So this file is going to be able to tell me, actually, one of the other things that you're going to see is inside the wildfire submissions, you'll typically see a breakdown of what that file did. So this is the start, and these are the on-firewall reports that you get. It gives you a breakdown of what all this file did, the fact that it created modified files, the fact that it reached out to different DNS queries, the fact that it was creating, read, writing, deleting files on my endpoint. The breakdown is actually done and should come up here. I stalled enough, so it worked out. You'll see here that we observed these different behaviors in that file, connecting to non-standard HTTP ports, which is one of the things you guys saw. Connecting to a malware domain, deleting itself, all of these kinds of actions are very, very highly suspicious, and you can see that the risk here is indicative of that. As you go down the list, you'll see other things. The fact that it used SSL doesn't necessarily mean it's bad, but malware does tend to use that as well. Going through now the breakdown of the actual process activity, autofocus has taken all the indicators of compromise from this list that's very just top to bottom in order. Autofocus actually breaks this down into very distinct categories of highly suspect, suspect, and uninteresting, and shows you that, for example, in the connection activity, these 8 or 10 actions, when you look at the number of samples that we've seen, both good and bad, and Wildfire has seen millions of samples, they see hundreds of thousands of samples a day, like unique samples. When you look at the number of samples that did this process with this parameter, 0 benign samples did it, 272 malware samples, and 0 grayware samples did this. So you can see those numbers right here. This indicates that only bad processes that we've seen have been doing this parameter. And you can see it also goes down the list. So the higher the number on the malware side means it's more commoditized typically, and the lower the number can mean it may be more of a targeted attack. So this is a good indication of, is this just a spray and pray kind of an attack where you're just throwing it out there and hoping it hits a lot of people? Or is this a much more insidious kind of attack, and do I need to do something else around that? Same thing with DNS activity. Again, you can see we have my search string, so you can see that it actually responds to these, or it responds to that query, and it returns this. So you're going to see it was, again, only done in malware files. So it's a very good indicator that this file is actually doing something at least suspicious, but if not, highly suspect. And again, that's why we call it highly suspect items. What we can also do with these items is we can create miners. And what a miner is the ability to pull that data out and feed it back into the firewall or other tools. So on the firewall, we have this ability to use something called an external dynamic list. These EDLs, as we call them, are the firewall essentially pulling a server to pull in a list of IPs, URLs, domains that you want to block, just based on the fact that you may have seen something for, the banking Trojan or some ransomware du jour. So you can actually create sample miners that essentially pull out all of the IP addresses associated with these bad guys or the highly suspect ones, for example, and you can actually have the firewall consume this dynamically so that you then get protections across the board, across all of your firewalls, without having to go and manually update with every IP address that you've seen involved in an attack. This is very powerful, and automation is really going to be the key moving forward in networks as attacks grow in number and frequency and compute costs go down, more and more attackers are more easily able to launch successful attacks. Using automation is the only way we're really going to be able to catch up to those bad guys, essentially. It's the only way we're going to be able to keep pace with them. And so using tools like autofocus and the mind meld miners in there is a critical piece to automating network defenses. So I'll take a minute and set up a Q&A session if anybody has anything. I'm just going to pause my sharing. I don't know if the guys on the line, if we have any participants, any Q&A in the chat or anything like that. Can you guys let me know?
I do not.
Yeah, no.
Okay.
Hey, Chris, this is Luke. Yeah, thanks. That was a great presentation. I had a quick question for you. You were talking about geolocation and blocking geolocations. What about attackers that are using Onion browsers or Tor browsers? That are putting a couple hops in between, or a
sure.
A VPN.
So there's a few things that we can do
that?
there. Yeah, there's a few things we can do in there. We can pull in a list of the Tor exit node, the known Tor exit nodes, into the firewall via these dynamic IP lists or the EDLs. We can also block the Onion router application. So we actually have applications for Tor. So utilizing that, we can just block Tor outright. And so the ability to pull that stuff in, yeah, there's a lot of different ways that you can do those kind of protections. So I hope that answers your question.
It does.
Cool. Anything else? I'm happy to go any which way you guys want. I've got another 10 minutes or so before I've got to jump to the next meeting, as we all have packed back-to-back schedules. All right. Well, if anybody has anything, I can put up my contact information in the chat really quick. If anybody has anything else, feel free to email, feel free to contact your ConRes rep, and they'll put you in touch with either myself or one of the other highly qualified Palo Alto Networks SEs, and we'll get your questions answered. Thanks, everybody.
Thank you, Chris. That was
Thank you
a
very
great
much.
presentation.
Thank you very much.